Welcome to the deep dive. You're probably here because you want to cut through the noise and really grasp what matters in tech security, right?
Yeah.
Maybe you're prepping for something, or you just like knowing how things tick, under the hood.
hmm
Today, we're really focusing in on virtualized security. We'll explore key ideas from the VCTA Security 2024 certification. Think of it as a way to quickly get up to speed on securing modern virtual setups.
Exactly. We've got some practice exam questions. They might seem a bit dry on their own, perhaps,
Yeah, maybe.
but we're using them as a launch pad.
Yeah.
The mission today is really to pull out the practical, actionable insights for securing networks, endpoints,
Mhm.
all in virtual environments.
So not just answers, but the why behind them.
Right. Why they matter now.
Okay, let's dive straight in then. Network segmentation, it's always crucial, isn't it?
Absolutely.
But in virtual environments, well, it's a bit different. So first question, which NSX feature is responsible for providing network segmentation at the virtual machine level? And the answer is B, distributed firewall. Now, for someone maybe more used to traditional physical networks, how does this distributed firewall idea, how does it change things?
Well, it's a pretty fundamental shift, actually. Traditionally, you'd have physical firewalls at the edge, maybe some internal ones, big boxes.
Right, the hardware.
Exactly. The NSX distributed firewall, or DFW, it lives in the hypervisor right alongside the VMs. So it provides security right at the VM's virtual network card.
Okay, so the firewall is attached to the VM, essentially, not something traffic has to write through somewhere else.
Precisely. It means you can inspect traffic going in and out of each individual VM and apply specific security rules just for that machine, regardless of where it physically runs.
Ah, so you get that really fine-grained control, like putting a little security bubble around each VM.
That's a great way to put it. It decouples security from the physical network topology. In these dynamic environments where VMs pop up, move around, having security tied to the workload itself is, well, it's essential.
Makes sense. Dynamic security for dynamic environments.
You got it.
Okay, so that handles isolating VMs from each other. What about security inside the VM on the endpoint itself?
Good
Leads
question.
to our next one. What is the primary purpose of VMware Carbon Black Cloud? The answer here is A, endpoint detection and response, or EDR. We hear EDR thrown around a lot. What does it actually do? What does Carbon Black Cloud bring?
Right, so EDR is all about focusing on the endpoints, your laptops, servers, workstations. Think of traditional antivirus like checking IDs at the door for known criminals.
Okay.
EDR, like Carbon Black Cloud, is more like having detectives inside, constantly watching for any suspicious behavior, even if it's from someone whose ID looked okay at first.
So it's looking for patterns, unusual actions.
Exactly. Monitors processes, network connections, file changes, you name it, on the endpoint itself. If it spots something potentially malicious, even a novel threat, it flags it.
And then?
Then it helps you investigate what happened, sort of reconstruct the crime scene, and gives you tools to respond, to contain the threat, kick the attacker out, fix the damage.
So it's detection, investigation, and response. Much more active than just blocking known viruses.
Definitely. In today's world, you need that deeper visibility because attackers are sneaky. They often get past initial defenses. EDR gives you a fighting chance to catch them before they do real harm.
Got it. Okay, let's zoom back out to the network level. Question 3. What is the primary role of the NSX Manager in VMware NSXX? Answer. A. Provides centralized management and configuration of NSX components. So if the distributed firewall is doing the security enforcement at the VM level, what's the NSX Manager actually, managing?
Think of the NSX Manager as the brain or the control center for the entire NSX deployment. It's the single pane of glass, the place you go to configure everything.
Everything.
Any of your logical switches, your virtual routers, those distributed firewall rules we talked about,
Yeah.
security groups, IDS/IPS settings, basically all the networking and security constructs within NSX.
Okay, so it orchestrates the whole system. It pushes out the configurations to all the components, like the DFW.
Exactly. It ensures consistency. Imagine trying to manage firewall rules individually on hundreds or thousands of VMs. It'd be chaos.
Yeah, it wouldn't scale.
Right. The NSX Manager provides that essential centralized control and visibility, makes managing complex virtual networks actually feasible and efficient.
Okay, clear. Central command. Now, let's talk about when things go wrong. An incident happens. Question 4. In an incident response process, what is the first recommended action after detecting a security incident? The answer given is D. Isolate the affected system from the network.
Yeah, this one's critical.
Seems straightforward, but why is isolation the absolute first thing you do before you even know exactly what's happened?
Containment. It's all about limiting the damage, stopping the bleeding. As soon as you suspect a system is compromised, assume it could be used to attack other systems on your network.
Right, lateral movement.
Exactly. Pulling it off the network, isolating it, is the quickest way to prevent that spread. It's like closing the watertight doors on a ship. You contain the problem to that one system while you figure out what's going on. It buys you crucial time to investigate without the attacker potentially hopping to other machines, encrypting more data, or exfiltrating sensitive info.
So contain first, ask questions later. Well, investigate later.
In a nutshell, yes. Controlled isolation is paramount.
Okay. Now let's link back to segmentation. Question 5. Which of the following is a benefit of using microsegmentation in a virtualized environment? Correct answer is B. Prevents lateral movement of threats. We talked about the DFW providing segmentation between VMs. How is microsegmentation different or more specific?
Think of it as taking segmentation down to an even finer level. While the DFW puts walls around VMs, microsegmentation lets you build walls within the data center, often based on applications or tiers, even down to individual application processes if you need to.
Okay, so it's not just server to server, but potentially app to app, even if it's on the same network segment traditionally.
Precisely. You define policies saying, for example, this web server VM can only talk to this specific application server VM on this specific port, and the app server can only talk to this database VM. Nothing else.
So even if an attacker gets onto that web server,
their ability to move laterally to reach the database or other critical systems is severely restricted. They hit those microsegmentation walls.
right, it contains the breach within a much smaller zone.
Exactly. It dramatically shrinks the attack surface within your network. It's a really powerful concept for implementing zero trust principles inside the data center.
That makes a lot of sense. Okay, question 6 revisits the DFW. What is the purpose of the NSX distributed firewall? DFW. Answer again. B. Provide traffic inspection and security at the virtual machine level. We've hit this, but maybe reinforce why it's such a core piece.
It's worth hammering home because it's fundamentally different from traditional perimeter firewalls. Being distributed means the enforcement happens right at the source, at the VNIC of every VM.
Right inside the hypervisor.
Yes. So traffic between two VMs on the same physical host doesn't have to leave the host, go through physical firewall, and come back. The DFW inspects it right there.
Which must be way more efficient.
It is, for sure. Better performance, better scalability. But the key security benefit is that context. The firewall policy is attached to the VM, it moves with the VM, and it can be based on rich context, who the user is, what the VM is, security tags, not just IP addresses.
So much smarter, context-aware rules.
Exactly. True workload-centric security.
Okay. Now, beyond just allowing or blocking traffic, what about looking inside the traffic? Question 7. How does NSX IDS-PS help with network security? Answer B. It analyzes traffic to detect and prevent threats.
Right. So this adds another layer. Think of the firewall DFW as the security guard checking passes who's allowed to talk to whom.
Okay.
The IDS-ES is like looking inside the packages they're carrying or listening to the conversations. It analyzes the actual network traffic flowing between VMs.
Looking for what? Known attacks.
Known attack signatures, yes, but also anomalous behavior that might indicate an unknown threat or policy violation. The IDS intrusion detection system part just spots it and raises an alert.
And the IPS.
The IPS intrusion prevention system can go a step further and actively block the malicious traffic it detects in real time.
So it's proactively stopping threats that might get past basic firewall rules.
Precisely. It's looking for exploits, malware communication, unusual protocols, things that indicate an actual attack is in progress or being attempted. It complements the DFW for defense in depth.
Got it. Defense in depth. Okay, back to incident response for question 8. Which action is part of a basic incident response plan? Answer C includes isolating compromised systems, collecting forensic data, and applying remediation. We covered isolation. Why are the other two, forensics and remediation, so vital?
Well, after you've contained the immediate fire, you need to figure out how it started and how to prevent it from happening again.
Makes sense.
That's where forensics comes in. You collect evidence logs, memory dumps, network captures, disk images from the affected systems. This helps you understand the attacker's tactics, what tools they used, what data they accessed or stole, how they got in, the whole timeline.
So you can piece together the whole story.
Exactly. And that understanding is crucial for the next step, remediation. Based on the forensic findings, you clean up the mess. This might involve patching vulnerabilities the attacker exploited,
Okay.
removing malware or backdoors they left behind, rebuilding compromised systems, changing passwords, maybe improving security controls to block that attack vector in the future.
So it's contain, understand, then fix and improve
Yeah.
the whole cycle.
You can't just isolate and forget. You need the full process to properly recover and harden your environment against future attacks.
Right. Okay, question 9 is pretty direct. Which VMware product is used to detect and respond to endpoint threats in real time? Answer: D. VMware Carbon Black Cloud.
Yeah, we touched on this earlier with EDR. Carbon Black Cloud is VMware's flagship platform for that endpoint security piece.
And the real-time aspect is key here.
Absolutely. It's about continuous monitoring. It's not just scanning files periodically. It's watching processes, behavior, network connections on your endpoints constantly, using sophisticated analytics and threat intelligence to spot attacks as they happen and enable rapid response.
Proactive endpoint defense.
That's the goal. For your workstations, servers, keeping those endpoints secure in real time.
All right, final question, number 10, brings it back to microsegmentation. What is a common use case for VMware NSX microsegmentation? Answer B, restricting VM communication based on security policies. We understand the benefit is preventing lateral movement. Can you give us a really concrete, everyday example of how you'd use this?
Sure. A classic one is the three-tier application. You've got your web servers facing the users, your application servers doing the business logic, and your database servers holding the data.
Yep, standard setup.
With microsegmentation, you can write very specific NSX firewall rules, you'd say. Only allow traffic from the web server security group to the application server security group on port 8080.
Okay.
Then maybe only allow traffic from the application server group to the database server group on port 1433. And critically, deny all other traffic between these groups and deny any direct traffic from the web servers to the database servers.
Ah, so you explicitly define only the necessary communication paths. Everything else is blocked by default.
Exactly. It enforces the principle of least privilege at the network level.
Yeah.
Even if that web server gets popped, the attacker can't directly reach the database. They'd have to compromise the app server first, and even then they can only use the allowed path.
Makes it much, much harder for them to navigate and hit the crown jewels.
Precisely. It contains threats and makes your internal network far less permissive. That's a huge security win.
Well, this has been incredibly useful. So maybe a final thought for our listeners. As threats get more complex and these virtual environments get even more dynamic, how do you see these core ideas, segmentation, real-time detection, needing to evolve in the next few years?
That's the big question, isn't it? Maybe more automation, more AI driving the policies and responses, even tighter integration between network and endpoint. It's constantly evolving.
Something to keep thinking about for sure. How do we apply these principles effectively tomorrow and the day after? Thanks for joining us for this deep dive.
My pleasure.